That is really the direct effect on gut health that our lifestyle choices have. Now, if you haven't heard me talk lately, you might not know who I am. I'm Sarah Ballantyne. I blog at The Paleo Mom, and I was a medical researcher. I have a PhD in medical biophysics. I did 4 years of postdoctoral medical research in critical care medicine and epithelial cell biology before I had my first daughter. And I decided to take a break from medical research, in large part because I wanted to be the perfect mom. Yeah, that ship has sailed. But also because I was morbidly obese, and I suffered from 12 different health conditions, and I was having a really difficult time finding work-life balance. So I focused on life. And that also allowed me to focus on my health. And my health journey eventually brought me to a paleo diet. It managed to reverse all of my diseases. I discontinued 6 prescription medications. It contributed to my 120-pound weight loss. I credit the paleo diet and lifestyle for now being in the best health that I've ever been in. So my perspective when I talk about these topics comes both from my science background and my just inherent geekiness and desire to understand the detailed mechanisms of how my choices are working, but also my passion and my personal experience with living this and changing my life with these types of choices. So if you're like me and you had an autoimmune disease or 2 or 3, and you've come to the ancestral health movement, you've come to a paleo or a primal template in order to handle your autoimmune disease or other immune-related diseases, you're probably familiar with the paleo autoimmune protocol. So this is a more restrictive version of the paleo diet, and I really don't like using the word restrictive, even though it's technically true here. I prefer to think of it as a more specific version of the paleo diet, because what it does is it not only removes some foods that have immune-stimulating compounds in them that can be a problem for those of us who are more genetically susceptible to react to those foods, but it also changes our focus to an even greater focus on nutrient density. It encourages us to eat more organ meat, more seafood, more vegetables, to seek out the best quality foods that we can, and to also incorporate a large amount of variety in our diets. We do this, of course, with avoiding a few good foods like tomatoes, nuts, seeds, eggs, and that can be really challenging. We also have more of a focus on moderation when it comes to things like fructose, omega-6 polyunsaturated fats, caffeinated teas, coconut. All of these dietary choices, let's use the word choice here, they all come from our understanding of how food interacts with our body. And they are really targeted at immune regulation. So when you have an autoimmune disease or an immune disease, actually any chronic illness, one of the things going on there is that the immune system is not regulating itself properly. And so we make these diet choices based on regulating the immune system, and they do this in 3 ways. The first is nutrient density. So we're providing our bodies with the nutrients that the immune system actually needs in order for its regulatory mechanisms to function properly. It also provides us with the nutrients that our bodies need to heal damaged tissues. We're also making diet choices based on hormone regulation. So we're regulating insulin and insulin sensitivity, leptin, ghrelin, cortisol. These are all affected by our diet choices, and their regulation is really, really important when it comes to the immune system because all of these hormones directly impact how easily stimulated the immune system is, how turned on it is, how well regulated it is. So we need to regulate these hormones in order to regulate the immune system. And then probably what is one of our biggest focuses in the paleo movement in general is gut health. And this is incredibly important when it comes to autoimmune disease because a leaky gut, or more technically increased intestinal permeability, has been found in every autoimmune disease in which its presence has been investigated. Similarly, gut dysbiosis has been found in every autoimmune disease in which its presence has been investigated, and leaky gut and gut dysbiosis seem to go hand in hand. So this has led to the hypothesis that a abnormal gut environment, whether that's increased intestinal permeability, gut dysbiosis, or the combination, may be a prerequisite for autoimmune disease to develop. So that means not only do you need this genetic predisposition and you need a trigger, but you need a leaky gut, or you need a damaged gut, or you need the wrong kind of bacteria, or too many bacteria, or not enough bacteria growing in your gut. There has to be something wrong going on there. And when you consider that 80% of our immune system is housed in the tissues around our gut, it starts to make some sense that gut health would be really, really important to the development of autoimmune disease and also to the management of autoimmune disease using diet and lifestyle. But here is the crux of my talk. Gut health is not just about the food choices you make. And as you embark on this really specific diet, this diet that requires a lot of effort, it becomes even more important to focus on the lifestyle factors that impact gut health, because you're going to all this effort. You are working so hard to make the right choices. You're doing all of this cooking. You're going out to farms. You're spending more money on your groceries. And if you don't get these lifestyle factors in place, you may not see results for your effort. And I can tell you there is nothing more frustrating than putting a ton of effort into your diet, feeling horribly deprived, and not seeing a benefit from it. A huge variety of lifestyle factors actually directly impact the health of the gut. This is not indirect, this is direct. And what I'm going to talk about today is how stress, how much stress you're under, how well managed it is, how much activity you do, what type of activity you do, and also how well entrenched your circadian rhythms are and how those directly impact gut health. So if I'm going to talk about gut health, it's probably good to do some basic physiology right now. When I'm talking about the gut, what I'm really talking about is the small intestine. So the small intestine is that big tube that joins your stomach to your large intestine, which is another big tube. The small intestine is longer and smaller in diameter, hence the word small. And this is where basically the majority of digestion occurs. And this is where the majority of nutrient absorption occurs. So it's an incredibly important organ. And if you think about this, if you didn't have a small intestine, if your small intestine is not working properly, you can't absorb the nutrients that every tissue in your body needs. This is a vital organ. We need our small intestine. And it's actually a pretty cool organ, except for the part where it's full of gross stuff. It has a structure that is designed to increase surface area. And actually, every time you magnify, you look at it with a microscope and you look closer and closer and closer, it still has structures that increase surface area. So it's these structures that fold upon these structures that fold upon these structures that fold. And if you actually unfolded the entire small intestine, you would have a surface area about the same size as a tennis court. So think about that for a second. Your small intestine inside your body, you unfolded it, tennis court. That's pretty big. So the largest structures are called the plicae circularis. These are the macroscopic folds, the ones that you could see if you were actually looking at someone's small intestine, which I hope you're only doing under very controlled conditions. When you look more microscopically than that, you see these structures that are like columns. They're often described as hills and valleys, but they're like Dr. Seuss hills because they're really, really steep. They're more like bunch of fingers together. They're called villi, and the valleys are called crypts. These are actually the dominant structure that really gives surface area to the small intestine. And they're really, really important. This entire surface is really formed from one continuous sheet of a highly specialized type of cell called an epithelial cell. These cells are, I've studied epithelial cell biology, so I can tell you from I spent 2 hours studying these cells, or 2 years studying these cells. They're super cool. I never, ever got bored. Yeah, right. Epithelial cells have a top and a bottom. And that's really, really important because not every cell in your body has a top and a bottom. So the top, which is called the apical side, and this is when we're talking about the gut epithelium, is the side facing inside your gut, which is actually outside your body. I know, mind blown right now. This apical side of the cell membrane has, again, structures designed to increase surface area. They're more microscopic than villi, so we call them microvilli. And again, they're sort of finger-like projections. And their entire purpose is to increase the amount of outside of the cell that the cell can interact with. The rest of the membrane is a different structure. It doesn't have these microvilli. The rest of the membrane, we lump the sides and the bottom together because the cell doesn't really know the difference between sides and bottom. It's called the basolateral membrane. The cell has a very specialized structure that helps it know the difference between its apical membrane and its basolateral membrane. And this structure is very relevant to everything I'm going to be talking about today. It's called a tight junction. Tight junctions are essential for epithelial cell health. And in fact, if you take epithelial cells and you grow them in a petri dish and you do something to them to disrupt their tight junction, they turn into cancer. So tight junctions are phenomenally important for these cells to maintain what's called cell polarity, which basically means the cell can keep track of which side's the top and which side's the bottom. It's also really important for the integrity of the epithelial barrier. So these tight junctions actually control how easy it is for substances to cross that epithelial barrier, and that's really what we're talking about when we talk about leaky gut. We're talking about the epithelial barrier no longer being able to control what crosses it. I want to show you just a little bit of how complex these tight junctions are. They're phenomenally important, and I have done a lot of microscopy staining for these proteins in the past. It's generally a structure made up of a transmembrane protein, so proteins that start from the inside of the cell, go through the membrane, and end up on the outside of the cell. And they're very tangly, bent proteins, and they kind of interlock, and they form like a knot. Now, if you can think of a knot, you can loosen the knot a little bit. That opens the tight junction and allows some things to travel through. You can close that knot, tighten it. And now you've closed the tight junction, and now things can't travel through as easily. The tight junction is a highly regulated structure within the cell. The cell has dozens of proteins that help control how exactly all of these proteins link so that it can control how open or closed the tight junction is. It is a dynamic structure. So it's not permanently closed. The cell actually opens and closes it in a controlled way to purposefully allow substances to travel paracellularly, which means between the cells, across the epithelial barrier. And I love showing transmission electron microscope images because they're pretty. This is the top of the cell. So these are actually the microvilli. This is two cells side by side, and they would go like straight through the floor. That's how magnified we're looking at them. And this dark area right here is the tight junction. What makes it dark on electron microscopy is the density of proteins that are there interacting with each other, forming this really complex. And it's integral to the integrity of an epithelial barrier. So when we're talking about gut health, we're really talking about epithelial cell health and how well controlled that tight junction is. So how well the cell can actually decide whether or not that tight junction is open or closed. And I'm going to start with stress. It is well known that stress increases intestinal permeability. It is well known that stress decreases digestion by decreasing gut motility, decreasing mucus production, inhibiting pancreatic secretions, inhibiting gallbladder function. It inhibits the gut immune system. And because it slows down digestion, it changes the environment for microorganisms. It is permissive for gut dysbiosis and overgrowth. So stress is a big deal, and this is fairly well understood. But what's really important to understand when we're talking about stress, we're not just talking about, a lion is chasing me, or I'm stuck in a traffic jam, which really our bodies see as being the same thing. It is activation of the hypothalamic pituitary adrenal axis, or the HPA axis. So the hippocampus is the area of the brain that really assembles information from our senses and kind of goes, okay, wait, there's a lion, or bad traffic. It sends signals to the hypothalamus, which is really the area of the brain that has a lot of control when it comes to hormones. The hypothalamus is really like the hormone controller area of the brain. The hypothalamus goes, great, lion, we got to do something. And it releases corticotropin-releasing hormone, or CRH. Corticotropin-releasing hormone goes to the pituitary gland, which sees it and goes, oh, lion, or traffic jam. Time to get the adrenal glands going. So it releases, and please only make me say this once, adrenocorticotropic hormone, or ACTH. I'm going to ACTH from now on. It's just too many syllables. And ACTH travels to the adrenal glands and says, hey guys, time to get going. And adrenal glands release all the things that they release. So that's cortisol, which is going to be most relevant to our discussion today, but also catecholamines like adrenaline. Now, what's really important about the HPA axis is that there's a built-in control. When cortisol is traveling through the blood, it sends signals back to the pituitary gland and to the hypothalamus that, okay guys, we got the message, we understand, traffic jam, we're lying, we're on it. And cortisol is really important for diverting resources to the brain for heightened decision making, and to muscles for running away from the traffic jam. And so it's telling the brain at the same time that it understands that we've got this stress and we're doing our job. And I'm going to come back to that negative feedback in a second. Let's start with cortisol. We think of cortisol as the master stress hormone. So clearly cortisol has a role in everything. It has actually a very important role in gut health, but maybe not the role that you're thinking of right now, because cortisol actually regulates tight junctions and it tightens them. So we think of stress increases intestinal permeability, but cortisol actually decreases intestinal permeability. How is that working? Well, cortisol is actually a natural hormone. As much as it's part of the fight or flight response, it's also a circadian rhythm hormone. It's also a metabolism hormone. It helps us access stored energy between meals. So it's really important to understand that cortisol has these normal roles in the human body, and one of them is very, very likely helping the gut epithelium to regulate absorption of nutrients after a meal when it's low, and it allows tight junctions to open, and between meals when it's higher and tight junctions are closed when there's not necessarily things to be absorbing. The problem is when cortisol is too high or too low. So too low might happen, an example for Addison's disease or chronic adrenal insufficiency, or what we lay people call adrenal fatigue. When you've gone so long, going so high, that your adrenal glands have basically said, like, okay, we're done, we quit, this is not the job we signed up for. And now your body is chronically producing too low of cortisol. I have extensive personal experience with this. And then what happens is that actually opens up the tight junctions, it causes leaky gut. So adrenal fatigue in that burnout phase, just automatically by the nature of having low cortisol, causes a leaky gut. So normal high cortisol is good, but then really high cortisol, again, it alters the structure of the tight junction, but now in a more complex way. So it's not as simple as saying, oh, it makes it leaky again. It makes the tight junctions more permeable to small molecular weight substances, so small things can cross, and it makes it less permeable to high molecular weight substances. So there's a give and take there. And the details of exactly why and what the impact in that is still something that's being studied. But when we're talking about cortisol, a lot of the studies, how we understand the effects of cortisol is by adding exogenous cortisol. And we do that by treating with steroids, like prednisone. And what we know is that when somebody's having an autoimmune disease flare and we treat them with steroids, it actually tightens up the tight junctions and it decreases intestinal permeability. That's one of the reasons why prednisone can be a life-saving medication during an autoimmune flare. And it does this, and this is the really important part, through glucocorticoid receptor binding. So cortisol has its effect through binding with a variety of different types of cortisol receptors throughout the body. And it's this binding that is responsible for the action on tight junctions. And this is really important because when you're under chronic stress, in a situation that's completely analogous to loss of insulin sensitivity, when you're eating way too much sugar and your insulin's chronically high, and then eventually your cells just aren't as sensitive to insulin, you have insulin resistance, we have cortisol resistance, or more technically cortisol receptor resistance. And that is one of the detrimental effects to chronic stress. And so even though your cortisol may be high because you're chronically stressed and your adrenal glands haven't given up the ghost yet, you may be causing a leaky gut because you've got cortisol receptor resistance. And this is something that is still a hypothesis that has not yet been investigated. But the HPA axis, as I already described, as much as cortisol is important, it's not all about cortisol. And I want to talk about corticotropin releasing hormone, or CRH, because its impact on gut health is probably more profound than cortisol. And this is really interesting to me because when you talk about adrenal burnout, when you talk about adrenal fatigue, you're not producing enough cortisol, you're also losing that feedback. So what happens is you're stressed, so you've been in traffic for a really, really long time, and now there's an angry driver behind you, and it just like totally is the worst day ever. your coffee spilled on you, your kid cried when you left the house, awful. Your adrenal glands have given up. So your brain is perceiving stress. It's telling your hypothalamus to produce CRH. Your hypothalamus